Hello, I'm Sochi from New York University. I'm excited to share our latest work on ActFormer, scalable collaborative perception via active queries. Today, I will walk you through our approach to enhance autonomous driving systems through efficient collaboration among multiple robots. We'll go first through background and motivation, then introduce our approach and results. Autonomous driving has made significant strides, but challenges still remain, particularly in single-agent long-range perception. The sparse data from 3D sensors and frequent occlusions limit a single robot's view. This is where collaborative perception comes in, offering a promising solution by sharing information among robots to achieve a more comprehensive understanding of the environment. Vehicle-to-vehicle communication could reduce the number of accidents significantly. With collaborative perception, we can leverage more viewpoints and modalities, see further and better, and even through occlusions. Here are the related works. Our work builds on the foundations laid by previous collaborative techniques, such as attention-based handshakes and graph neural networks. However, they often treat all viewpoints equally, which can lead to inefficiencies. Our approach addresses this by using spatial information to actively request and utilize sensor data more intelligently. We also need to point out the difference here from where to come. It obtains a confidence map based on the fusion module, while our query selection happens locally based purely on the ego agent perception and only the poses. It's a decision-making process made by the ego vehicle, and others don't need to transfer full features. Here's our motivation. Current collaborative methods face challenges when it comes to scalability. They often require dense communication with equal viewpoints, which can be impractical with a large number of agents, because communication may not be necessary when some partners share very similar observations, causing potential waste of bandwidth. So we ask, can we create a framework that actively exchanges only useful information, that is spatial knowledge, and scales collaboration regardless of the number of agents involved? Instead of equally querying all camera inputs at all locations, we select a group of 3D to 2D BEV queries based on agents' relative poses to aggregated features from multi-robot and multi-camera inputs. Then we get a scalable and efficient collaborative perception framework that refrains from querying repeated information based on ego agent spatial knowledge and free from scaling dependency with number of pairs, also not relying on the sensory measurements. Here we introduce our approach. It's a transformer-based architecture that learns pose embeddings and concasts them with BV queries to produce an interest score map from multiple cameras on different robots. Interest score map is mapped multiplied by the BEV query using a gated network for query selection. Then ActFormer enables active select sparse queries while maintains perception accuracy without the need for extensive data transmission. The key of ActFormer is the concept of pose-guided selective attention. The ego vehicle project selected queries to the corresponding poses and the 2D camera points, then aggregate information to update the ego agent's BEV perception, which enables ego agents to emphasize its regions of interest to its peers. We evaluated ActFormer using the V2Act Sim dataset, which stimulates complex urban driving scenarios. Our experiments involved collaborative 3D object detection using both IOU and the box central distance metrics. Compared to collaborative BEV former baseline, the average precision achieves a better performance. The most important part is scalability and efficiency comparison demonstrated by the experiment results. In figure on the right, the Eagle car has 6 cameras, and we reduce the accuracy up to 40%, especially the camera that takes most information so that it saves the most amount of accuracy. The efficiency via different number of agents is shown in the figure on the left. Here's some simple interest map. The cars are at the crossroads so that the ego car selects the most important information of each car instead of all feature transferred to the ego car. What's interesting is the map outcomes different interests in different layers. At first, it chooses to get features everywhere, and then selectively acquires based on each partner's pose. In conclusion, Act Former represents a significant step forward in scalable collaborative perception for autonomous driving. By utilizing the posing of collaborative partners and actively select a sparse set of BV queries, our method improves the detection performance and especially efficiency, making it a possible solution for multi-agent perception systems. Thanks for listening.